All right, so our next segment is a slide that starts with letter C. It's mineral cleavage. And while that word has developed a reputation that is probably not appropriate for discussion here, I want you to think about something like a meat cleaver, which is basically used for cutting something. And so cleavage, if you read the definition in terms of minerals, it means the tendency of a mineral to break or cleave in a pattern to form certain, either it'll form parallel sides or very oddly smooth sides when you hit it with a hammer or something like that, which we'll do in a minute. So cleavage is about breakage, and another similar use for the word is in cell division in biology. When you talk about mitosis, the final step after a lot of the phases have completed for cell division is called mitosis. In mitosis, it's called cleavage. It's the actual breaking of the cell into two identical daughter cells after the genetics have been replicated and all that. So it really has to do with breakage. And so for minerals, we have some very obvious patterns out there in mineral when you break them or break them away from wherever you find them, or if you take a piece that you have like this and you hit it with a hammer, it's going to break a certain way. One of my favorites is this one. This is calcite, which I can kind of bring closer to you. You'll notice it has it almost looks like a parallelogram in math, where it has these two pairs of parallel sides. Like that, it actually has three pairs of parallel sides. If you think of top, bottom, left, right, and then front and back. So it's what's bizarre about this particular sample is when you hit this, it'll make little pieces that all look like that. They'll just be smaller versions of this parent sample. I'm not going to do that to this one because this one's too pretty, and we like the perfect looking ones that are parallelograms like this. But a little review, this has a glassy, pearly, iridescent luster. If you actually shine a light on this, you'll see little prisms or rainbows on there. And it also is not the hardest mineral in the world. It's a little harder than my fingernail, so it's a little bit more than 2.5, but less than the iron nail, which is 5.5. So that's why you see a lot of scratches in this already, because other students have used this and created scratches in this mineral with a nail. So that's calcite, and that is what we say is a cleavage pattern in that mineral of breakage. And you can see similar ones. What you'll notice besides the parallel sides is there's a certain glare to it. You see when I twirl that, that's actually sunlight bouncing off of it right there. And you can sort of see that glow or flash. That's called glare. Your iPhones will do that, or any phone will do that. If it's in the passenger seat and the sun hits it in the right direction, it'll cause a glare or reflection that actually can blind you temporarily, so it's kind of dangerous. Other mineral samples that have similar look, this is a potassium feldspar. You can see that big, smooth-ish side that has a common glare right there. And there are other sides that are parallel and smooth also. Not so smooth necessarily, but certainly you can see sharp corners that are consistent. That's another indicator that this thing will break in a pattern if I hit it with a hammer. And by the way, good thing to note, all minerals have places like this that are irregular. That might have been where it was attached to another rock and they broke it off, and that's not necessarily pure mineral, but we're really looking at, mostly that, where you see that nice shine, and on that side as well. And those two sides are parallel. Obviously they're completely aligned with each other, which is amazing. And that just happens in nature. A couple other patterns of cleavage that you might see. This is our sample. I've showed you this before. This is one of the mica samples. This is muscovite mica. Ooh, there's that glare that you're seeing is a dead giveaway for a cleavage pattern. But the other thing is that all the pieces look the same. They look like sheets. And if I were to zoom in on the side of this, it's not really possible, but you can almost see that there are little lines in there, or would see that there are little lines in there that are actually little sheets, and I can break off pieces of this that are just more sheets. So that's a cleavage pattern as well. Now sometimes it's not so obvious. I've got a nice purple one here called fluorite. This one actually is pretty good. You'll see some glare off of some of the sides here, and they're oddly glaring all at once. that shine that you see all at the same time, that is usually a dead giveaway for cleavage pattern. However, sometimes it's not always obvious looking at it, but shining a light through there, do you see how there are cracks in there? And there's another one right here. I'm going to try and maneuver this. See that other where there's a crack that looks flat in there? That means that if I hit this with a hammer, you're going to see it probably break right along that crack. And you'll notice on some of them, the cracks are kind of aligned or show a pattern. Like this one, you're going to see a lot of triangles. And this one is called fluorite. So you can almost see that some of this has a triangular shape to it already. And within this, there are cracks that are triangular in shape as well. So that's a kind of a hint that maybe if I were to hit this, it would probably break in a certain way. Look at that triangular glare right there at the tip there. So that's another one that shows that. Now, other samples of the same mineral, by the way, which can have different colors, I mean, you look at it, it looks pretty rough, to be honest. But within there, again, maybe if I can shine some light in there, you might see some cracks that are kind of triangular in shape. There are a couple of lines in there that are parallel to each other, and you can sort of see some triangular points on there. That's even though this isn't a great sample of fluorite, and it's a totally different color than purple, by the way, that does indicate that if I were to hit this, there might be a pattern in the pieces. So that's a kind of a little saying you can remember, pattern in the pieces. That means the mineral does show cleavage. So what I've got here is I tried to find an ugly one, and you can sort of see there's cracks in it though, which again, that's a giveaway that there is going to be a pattern of cleavage here, and those cracks are fairly straight in alignment, and you can see there's a parallelism there. I got a cutting board here, and I've got a little hammer. I'm just gonna give this a little pop. And when you do that, in the pieces, look at the brand new, shiny, flat side that I've made. And it's not perfectly flat, but the glare comes off of that all at the same time. And you might even see down here, this little guy is actually a cubic shape. Let me see if I can get some better light on that. Just looks like a big glare there. But you can see there's little 90-degree corners on it. Get it right up to you. Little 90-degree corners, and kind of cubic in nature. And if you look down at the other pieces, you'll see a lot of square corners and edges on it. And that is because, there's another one right there, that's because it breaks in a pattern. And even these little ones that don't look like they're squares, if I were to zoom in on those, you'd see it. Here's another little piece that broke off. And you can see still it's got some 90-degree corners in it. And again, over here, this one, same thing. So that is a pattern of pieces where a lot of them have 90-degree corners and certainly have some flat parallel sides. And the glare that you get is such a dead giveaway that the whole side, even though it isn't all the same kind of level, the whole side will glare at the same time. If I can get that to do that again, that would be great. So it shines continuously and from all parts of that side of the mineral at the same time. And if I did that for other pieces that broke off, see there's another one, nice flashy, flat, brand new side. Now the reason it's so shiny is because that's a freshly exposed side. It has never been handled. It's been kind of protected inside that mineral sample for years and years and years. And now here I go and I just bust it up, and you get these nice shiny sides to it. And I'm going to show you the parent mineral here is actually this one. Here's a nice chunk of pure sample. This is actually the same as the one I just hit. And this is called halite. And you may know that already, and it may be familiar to you, because if you taste this mineral, which you should not, it will taste very salty because it's basically sodium chloride, which is table salt. So when we buy table salt at the store, they just take it and they smash it up a whole lot, and you get little tiny grains of salt. But put those under a microscope, I promise you, they all look like little squares or cubes, and that's an amazing thing. So you can see the big one still looks like squares or cubes, or rectangular shapes. Again, flat sides that have have a glare to it. You can see that shine again. And 90-degree corners, parallelism. There's parallel sides here, here, and here. And this happens to be a cubic pattern of cleavage, which halite is well known for. So kind of a neat thing that minerals do is break like that. And of course, in the slides, it says that that is the way this all happens is due to the internal arrangement of atoms, as always, with anything in minerals. And it gives you a few other examples, kind of the ones I just went over. It shows calcite, halite, mica, and fluorite. I actually kind of randomly picked those, but it happened to be the ones that are in the slide. And then it lastly talks about minerals that don't do this. Well, what happens if you hit something and it just makes a mess? Like this, if I were to have broken this off of a big sample somewhere else and looked at it, this is what I get. Notice it's very rough and there's kind of like shiny spots on it, but it doesn't glare all at the same time anymore. You've basically messed this mineral up. This is what we call a fracture pattern. Now this is a good thing I'm going to talk about in a second. Okay, I'm going to address that. That's a flat side. Notice it doesn't shine though, which is interesting. Not as much as some of the other samples I've shown you. So this, when you break it, you're going to get these awfully rough edges that look very jagged, sharp, and uneven, and there is no pattern. So that is what we call fracture, and that's several minerals show a pattern of cleavage, but many of them don't, and that's what fracture is. And you would see that even on something like this, which I'm going to show you. This is quartz. Look at the end of that and how rough that is. And I'm going to talk to you now about how some minerals show these flat sides, and that even shines a little bit. It's not shiny, but it's kind of has a little bit of a glare to it. And then this one, I mean, look at how shiny they are. And some of them might even look parallel. But doesn't it look kind of like it's like a crystal spike that you'd see growing in a cave or something like that? And that is because that is the way this mineral grows when it forms based on chemistry. But it creates a pattern, a crystal pattern that looks like these hexagonal prisms like this. And it just happens to grow these smooth flat sides, and it's beautiful just due to the silicon and oxygen and the way they spin around when they form. But if I were to snap that off, this was a part of a big long spike, much longer than the one you see here, but if I snap it off, what I get is this ugly, uneven, messed up, cloudy looking fracture. And that's what happens when you hit this. And the same goes for this one right here. This is actually garnet, which is a birthstone, or it can be when it's polished. It's a mess, but it can grow and have smooth flat sides that have grown like that as the mineral formed. But in reality, when you snap it off or break it, you get this ugly, sharp, jagged, uneven pattern, or a lack of pattern. That's called fracture. So that's a little about mineral cleavage and whether it does or doesn't, and if it doesn't, it's called fracture.